Hello everyone, this is the sixth lesson of physics 6.6 ultrasound. So in the previous lessons we were talking about sound, we talked about waves, firstly kinds of waves, then we took example of sound waves. Then in the last lesson we talked about hearing range. We said we can hear the sounds that has frequency between 20 and 20,000 hertz. Today we'll talk about a kind of sound. We called it ultrasound. Ultra, the word ultra, it means above. So above what? Above the 20,000 hertz. What's that mean? It's we cannot hear this kind of sound. So here, as you can see, this we called it ultrasound. The frequency of it range between above to 20,000 until the 120,000 hertz. So the human ear can detect sounds up to the frequency of 20,000 hertz, as we said before. Okay, sounds above the range of a human hearing are called ultrasounds. So a definition, if you want to give a definition for ultrasounds, we will say it's sounds above the range of a human hearing. Here we have some uses of ultrasound, or for what do we use ultrasound, or how we can get benefit from this ultrasounds. Cleaning and breaking. Using ultrasound, delicate machinery can be cleaned without dismantling it. The machinery is immersed in a tank of liquid. Then the vibrations of high power ultrasound are used to dislodge the bits of dirt and grease. In hospitals, concentrated beams of ultrasound can be used up to break kidney stones and gallstones. We will talk about this example because, of course, all of you heard about this example. They say, for example, you will have stones in your kidney. Okay, these stones, it's harmful, it's painful, so you should get rid from it. How you can break this? How you can break these stones? It's by using ultrasound. So they pass ultrasound to your kidney. These ultrasounds, they are vibrating, but they are vibrating high. Okay, so the number of vibrations, it's high. So in this case, what will happen? These vibrations, it will hit the stone many times, and then it will break it. It's like they use this ultrasounds as a hammer. Okay, so this vibrations of ultrasound, it will break the stones into smaller pieces, and then then it will goes out of the body. Number 2, echo sounding. In echo sounding, we talked about it. We talked about echo sounding before. Echo sounding, it's like what? Here it's ship. So they are trying to find that, for example, the depth of this sea. Okay, how it works? We say here we have echo sounder. It will send a sound. It will send ultrasound. This ultrasound, it goes through water. When it will hit the bottom of the sea, it will be reflected. So it will reflect up. So here what is happening, the waves or the ultrasound waves are going down, then up. So how they will find the depth? Firstly, they know the speed of this ultrasounds in water, and then they will calculate the time from when it's like when it sends the wave until it will receive it. So here what they will have they know the speed of waves in water and also they will calculate, they will find the time, okay? Then if they know the time and the speed, they can find the distance traveled by using this formula. Distance traveled equal to speed. They know how much is the speed of ultrasound in water, and they will find that they will calculate, they will measure the time it will take, okay? They know speed, they measure time, so they can calculate the distance. Example here, for example, if here it says the speed of sound in water, it's 1400 meter per second times 0.1, the time it's 0.1 second, so the depth will be 140 meters. But ultrasound has to travel down and back, so depth of water, it's half times 140 equal to 70. Here it's step number 1. Here it's step number 2. Here when they calculate this one, the time, okay, the time it was total for going and coming, okay. Now they got 140 meter. That means the sound it traveled 140 meter, but in fact this 140 meter is not the depth, because now this 140 meters, it's what? It's for going and coming, so it's for 2. So what we will do, we will divide it by half, so we will get 70 meters. Another example, bat or bats. Bats, how bats here, it's by sending. As we know, bats, they are always flying during night, and night it's dark, so they cannot see. So how they are adapted to this behavior, what they will do, they will send, as you can see, they have this large ears, okay. So they will send echo, or they will send this ultrasounds, okay. When it hit any object, so it will be reflected to the ears, and when it will reflect to the ears, the bat, it can detect what kind of object or what there is in front of it. So this bat uses ultrasound to locate insects and other objects in front of it. It sends out a series of ultrasound pulses and uses specially shaped ears to pick up the reflection. Another uses for ultrasound, it's for metal testing. What do you mean by metal testing? For example, the echo sounding principle can be used to detect flows in metal. What do you mean by flows in metal? For example, let's say this is a metal, okay. This is a metal. Metals, it should be there shouldn't be any gaps or holes inside it, okay. So but if you look at this piece of metal, okay, focus on this white part, this white hole, this white dot. Here it's what? Here this piece of metal, it has a hole inside it. A hole inside it, we cannot see it, but how we can detect it? By using ultrasound. So here, as you can see, ultrasound transmitter detector. Here, the ultrasound here will send the waves. When it will pass here, so they should get the same result here. But see, pulse send out, pulse reflected from flow, pulse reflected from end. So here what is happening, as you can see, there is a difference in the reflected waves. So what's that mean? When the waves are not equal or not the same, that means there is a flow inside the metal. Scanning the womb. Scanning the womb, what do you mean by it? As you can see this picture, it's when a pregnant woman. So what they do, they use ultrasound waves, okay, to detect the embryo. Okay, a pregnant mother in the photograph below is having her womb scanned by ultrasound. Okay, here it's the same principle. It will send waves to the womb. The womb will reflect it depending on the shape of the embryo, and then as you can see here, we will get a picture as it's shown here. That was everything for ultrasound, and also the definition of ultrasound, uses of ultrasound. Okay, so your task for this lesson, it's solving these questions. Have a good day. Thank you.